Okay, good morning all. If you observe,
Good morning, sir.
uh, there was no scheduled, I think. Saturday, actually, there was discussion regarding this, but I didn't remember actually. Otherwise, yesterday I have managed the thing regarding the schedule. But at present, I have done the schedule on the calendar of this mail, but that didn't work actually. Probably on the next lecture there may possibility that that should be work. But why the schedule has been removed, that I will check today. And again, uh, we have to focus that if such kind of situation is there, then we have to send the link and join the. I think this problem was since last 1 2 days or just today only. So whether
सर
the
आजच होतंय. आधी झाले होते जॉईन आम्ही. आजच झाले
अ,
नाही
क-
जॉईन.
म्हणजे आजच जॉईन होता आला नाही ना.
हां सर. Bergen ma'am was also saying sir that
बर्गे
there is some
मॅडमलाही तोच
problem.
प्रॉब्लेम आला होता का?
हो.
ओके, म्हणजे मागच्या शनिवारी लेक्चर मधलं शेड्यूल कोणीतरी काढलेलं दिसतंय आणि त्यामुळे तो प्रॉब्लेम दिसतोय. बघूया आता पुढच्या ह्याच्यामध्ये त्यांनी कसं शेड्यूल टाकलंय किंवा तो काय प्रकार आहे, मी तो थोडासा ऑब्झर्व करतो आणि त्याच्याशिवाय मग आपल्याला समजणार नाही. आणि आता मुलांच्या मध्ये मला वाटतंय हु अबसेंट, काकडे इज हिअर का ही हॅज नॉट जॉईन. आय थिंक काकडे इज नॉट जॉईन ना. So Raj is not observed over here. So again we observed 2 3 students are not attend the lecture. Even though most of the students from analytical chemistry, uh, they have joined the online course, almost 16, right? But today on lecture there are only 13. So uh, where are remaining 3 students?
सर सगळ्यांनी केलंय जॉईन. एक जण नाव ऍड करायचं राहिले.
कशामध्ये?
ते स्वयंसाठी
हो ना, मग
17 चे 17 जॉईन
17
केले.
केले. एक नाव नंतर ऍड झालं ना ते लिस्ट मध्ये. तू नंतर एक ऍड केले ते नाव कोणाच तरी.
हां. हां. तर अजून एक आहे स्नेहल गुजर पण राहिली. तिचं पण करते. तिचं उशीर
ओ,
आला रात्री मेसेज.
म्हणजे स्नेहल गुजरच राहिली का फक्त?
हां सर.
हा, 17 होत आहेत. पण जॉईन होत आज राजचा परत काहीतरी प्रॉब्लेम झालेला दिसतोय. राज काकडे एक दिसत नाहीये. अजून कोण राहिले? So we remember everyone should join the lecture, and almost we have 2 months we have already done. So that is nothing but the syllabus is now at the last stage of this. Almost we have done the 10 lectures. So almost within 1 2 lecture we will finish this topic, and then we will move to the another one. That is also very important topic. Now, in this, just we can see. I think everyone should join. No one is now able to join because 16 is nothing but 15 are there. 2 are not joined. One of them is Raj, and then who is other, that we will see later on. And just check whether the number is more than that and take the screenshot and send on the group. So as on last lecture we have started the analyzer. So different kind of analyzer we have already started. Analyzer are nothing but we have to separate the ions from the ion source when they are accelerated to the slit to the analyzer on the basis of individual mass to charge ratio, they can be transferred to the detector, or they can be fall on detector, and the number of different mass analyzers that are available in the along with the instrument. So in that we have seen mostly the two forces that work simultaneously, that is Lorentz force equation, Newton's second law of motion, and then we have observed by using the equation how they can work in detail. And after that we have seen the uh, one by one the mass analyzer. First is single focusing magnetic sector, that is magnetic deflection, and along with that we have observed when electric field is also applied, that is double focusing mass spectrometer, and in that we have carried out the transfer of ions on the basis of their mass to charge ratio. Then we have seen the very important analyzer, that is quadruple mass analyzer and quadruple ion trap analyzer. So in this case there is a cylindrical, through these four different cylindrical having a opposite charge, and through which we can pass the ions, and those who are in red color, they can directly go to the detector, while the that is the resonant ions, they can be directly passed, while the remaining are vanished, they can be collapse on these poles, or they can escape through this. So we have observed that in the tandem mass spectrometry, generally such kind of system, this is a single we can simply call it as it is a single quadruple mass analyzer. But in tandem mass spectrometry, such kind of single quadruple, they are attached more than one, that is three quadruple such systems are there, one after another, and they can pass through this. So such kind of filter is there, and through which we can obtain uh, mass to charge ratio of respective ions. And that's why that tandem, so that is nothing but along with GCMS, LCMS, MSMS. So such kind of technique nowadays used in the instrument, it is called as tandem mass spectrometry. Then in that case commonly they use a three quadruple mass analyzer, and along with that there is resolution is also there. So a number of modified techniques that has been used in that case. So, and after that we have seen the quadruple ion trap analyzer. This is a 3D ion trap kind of analyzer is there. So that having radio frequencies, and through this we can obtain the ions. So this is the ion source, if you see in the vertical section, and below this there is a detector. So that system is called as quadruple ion trap analyzer. It is a 3D ion trap analyzer. Such kind of system is there. So these two parts we have seen in detail. Now today we will see the remaining important part of mass analyzer. No doubt it having a limited number as compared to the ion sources. So probably we will cover this part today. So that part we have seen. Now we will see the time of flight analyzer, that is called as TOF. This is commonly used along with MALDI, along with quadrupole, along with quadrupole ion trap, that is QIT, TOF analyzer. That is the name of instrument. So on the basis of which ion source is used, which analyzer is used, they can be give the name. And such tandem spectrometry, that is mass spectrometry, has been used nowadays. So the time of flight mass spectrometer, it is a non-scanning mass analyzer that emits the or transit from the sources, whatever the ions are there, so they can be directly passed through the accelerator, that having a equal kinetic energy. So before entering these ions in this region, there is a from ion source to detector, there is a flight tube. This flight tube, in which they can be accelerated, which having equal kinetic energy. And the time of flight instrument consists of pulse ions, accelerating grid, that is free flight tube in between this accelerating grid to the detector. And here actually the role of analyzer plays. So time of flight is, it is a very simple meaning is that how much time is required to transfer from this accelerated grid to detector. So how much time is required to reach from accelerating grid to the detector, that is measured in between this field, that is free flight tube. And here, as the kinetic energy is fixed, and that's why on the basis of their weight, that is m by z, the lighter ions can be having a more velocity. We know that kinetic energy equation. So that having more velocity, they can reach faster, and heavier ions that having a different mass by charge ratio is more, so they can reach later on. So such a basic thing on the basis of name of analyzer that we have to explain. That is basic principle, we remember. So there are different modes of time of flight analyzers are there. So they are used along with mass spectrometry. So mass analyzer is used as TOFMS. Here they can use a linear flight tube, that applying a bended geometry of flight path to reduce the influence of neutral particles, or employ the V type or more reflectrons, that is W type. So that is nothing but these are the path through which they can be passed, either V shape or W shape, to enhance the path length within a given flight tube. So we have say that here actually the mm, m by z ratio with different masses, they can be passed. They can be passed either in the shape of V or in the shape of W, and that is called as a reflectron that can gives high resolution. We remember this is a modified technique in which we can use the resolution. So linear top having high mass range but low mass resolution is there, and that modified TOF. So linear is a very preliminary stage of TOF analyzer, but when reflectron is have been included in that, then they use a lower mass range, and that gives a high mass resolution. And on the basis of this, V type and W type reflectrons are added in that case, and that can gives a separation with high molecular ions also. So this is the important part of this TOF analyzer. So if we see the TOF analyzer, uh, it is by time without use of any electric and magnetic field is there. So it is simply similar to the chromatography, except there is no stationary as well as mobile phase. Instead of that, the separation is based upon the kinetic energy and velocity of the ions. As from the accelerator, ions are accelerated by electric field with a known strength. This acceleration results in an ion having kinetic energy. And we know that the velocity of ion depends upon the mass to charge ratio. Heavier ions having of the same charge, that having less velocity, so they can reach having a speed slow, so they can reach to the detector at uh, more time as compared to the lighter ions. So the time that can basically takes the ions to reach the detector at a known distance that can be measured. So the again the time is depend upon the velocity of ions, and therefore we can measure the mass to charge ratio, and from the ratio and known experimental parameters we can easily find out the ions which are present. So if you observe here, the sample is passed through this inlet. These are the slits, so that can ionization take place over here, that is vacuum chamber hold this thing. And these are the slit that can accelerate the ions, and they having electric field is there, so they having a known kinetic energy. And if you observe smaller ions, they can be move faster, so its velocity is more, so they can reach to the detector at very low time as compared to the heavier ions. So on the basis of their velocity, so they can be uh, having a particular mass to charge ratio, and they having a different speed. So on the basis of different speed, they can be entered to the ion detector. So this is the time of flow of light. So this is the tube, that time is measured between this slit to the this slit. Okay, so this is the basic principle of TOF analyzer. So did you understand the meaning of TOF analyzer?
Yes, sir.
So it is very simple. Even though I have given in detail, because mm, it is very difficult to say at this stage whether the exam will be in offline mode or online mode. So mostly we can move towards the online mode, and at that time, if the exam is on the basis of MCQ or on the basis of short question, then you must focus on the points which are very important. So hope so we will come very soon in the physical mode. Otherwise, this semester is probably on online mode. But as other colleges are concerned, we are very much ahead because our syllabus is already started from July, and now we are end with September. So almost in 3 months, more than 50% syllabus is covered. So it is very easy that in October, that probably all syllabus will be finished. So on online mode, I think this is the first college that they will cover most of the thing. Now after this, we have to again focus on the practical also. So after finishing the exam of this last year, probably we'll focus on practical part also by virtual lab. Okay. So this is a very important part, and that's why these things are very important to know the basic concept regarding the instrumentation. Now we can see the benefit of this TOF. Again, it is a faster MS analyzer as compared to the rest of the. So mostly it is well suited to the ionization method along with MALDI. So MALDI TOF, that in the previous lecture also I have told that most of the sample of my research I have done on the basis of MALDI TOF and ESI TOF. So that depend of the MSMS, or we have used HRMS also. So that depend upon which instrument we can use. Okay, so this is a high end transmission is takes place. MSMS information is from the post source decay, and it is a highest practical mass range, all mass analyzer, and that's why this TOF is commonly used. So here, no doubt, it having a different advantages, but few disadvantages are also there. So that having required the pulse ionization method or ion beam switching. So fast digitizer used in TOF that can have a limited dynamic range, and precursor mostly ion sensitivity is having a very limited part, and that's why they're having a certain limitations. But for this almost they will apply in the MALDI, all MALDI system this is used, MALDI TOF, and along with GCMS, MSMS, this TOF is commonly used. No doubt the quadrupole TOF is also there, that is quadrupole TOF Q or quadrupole ion trap TOF, that is also commonly used. Now we can see how this can be worked. So this is some experimental part, that is the ions of the same charge as we have seen having equal kinetic energy, and kinetic energy of the ion in the flight tube is equal to the kinetic energy of ion that can lose sources. So kinetic energy is equal to 1 of mv square, that is Z phi. So here we can observe the time of flight, that is the time it takes for ions to travel the length of flight tube which having a particular velocity. So time of flight TF is equal to length of tube divided by the velocity of ion. So by substituting this value in equation number 1, we have observed that is the equation of 1 to in equation 2. So we have observed that is time of flight TF is equal to L into square root of m by z to square root of 1 upon 2v. So that is nothing but it is directly proportional to the square root of m by z, or in some cases we can observe when we can take squaring of this, then we can observe m by z is equal to tf square. So during this analysis, length of the tube, the voltage from the ion source are almost constant, so which can be used to say that time of flight is directly proportional to the root of mass to charge ratio. Unfortunately, at higher masses, resolution is very difficult because flight time is very long. Because as we can say that polymer uh, as well as more biomolecular compounds, they having very uh, high molecular weight. So in that case, the mass by charge ratio is also very high. So it requires more time. And also, not all ions of the same having the m by z ratio. So for this purpose, the resolution has been carried out in the TOF. So to fix this problem, a reflectron is added in the analyzer, that we have already seen. The reflectrons, that it may be in the V shape as well as in the W shape. So the reflectron consists of a series of ring electrodes of high voltage at the end of flight tube that had been uh, kept, and when the ion travels into the reflectron, it is reflected in the opposite direction due to the high voltage. So this reflectron increases the resolution by narrowing the broadband range of flight time of a single MZ. So faster ions travel further into the reflectron and slower ion travel less into the reflectron. So this way, both slower as well as fast ions having the same MZ reach to the detector at the same time, and rather than at a different time. So this is the very important part, that in the resolution, when we can add a reflectron at the end side of the flight tube, they can be traverse the ions into the reflectron with high voltage in opposite direction. So on that basis, they can be adjust that all MZ coming to the same time reaches to the detector instead of one by one. Okay, so that is the role of reflectron. So did you understand the role of reflectron? So such kind of question is asked in bits as well as in the MCQ also. Be remember. So that's why I have given in detail, because if you don't have any kind of book, so you should take the print of all PDF that I have sent to Google Classroom. So that is very easy to understand the concept, and from that you should write down the important part in the exam, either in the physical or when they will do in online mode. Okay, so reflectron समजले सगळ्यांना? Any doubt is there?
No, sir.
Hmm?
No doubt, sir. No, sir.
ओके, रिफ्लेक्ट्रॉन हे पुढच्या डायग्राम मध्ये आपण चेक करूया. तुम्हाला दिसेल तिथे मी डायग्राम लावलेली. ओके, सॅम्पल प्लेट आहे, तिथे ग्रिड्स आहेत ज्यामधून सॅम्पल जो आहे इथून ऍक्च्युअली लेझर बीम पास केली जाते सॅम्पल प्लेटवर. आयनायझेशन तयार होत आहे, आयन्स फॉर्म होतात आणि ह्या स्लिट मधनं ते इकडे येत आहेत. इथे ऍक्सिलरेटर होत आहेत, इथं ऍक्सिलरेटर आहे आणि ऍक्सिलरेटर नंतर ह्या ठिकाणी ह्या सिलेक्टर मधून ते आतमध्ये जात आहेत. ह्या ठिकाणी टाइम ऑफ फ्लाईट आहे, इथे डिटेक्टर आहे आणि मग ह्या ठिकाणी हे जे काही हे लावलेले आहेत रिफ्लेक्ट्रॉन्स, आणि हा रिफ्लेक्ट्रॉन डिटेक्टर आहे. म्हणजे आयन्स इथं आल्यानंतर इथून ते रिवर्ट जातात. दॅट इज अ व्ही शेप. In some cases they having W shape and go to here. That is reflectron detector. So this is linear detector, that is very normal. Those who ions are not good in that reflectron, they can be reach over here. But the lighter, they can be reach over here in the V shape directly they can go, or in W shape they can be move and come to the reflector detector. So if you observe here, this is simple. This is laser. This is extraction that can accelerated is there, and the reflection is takes place. Then at the end of this, they can be moved. The ions are moved on the basis of their velocity with respect to the m by z ratio. The lighter ions move faster over here, and they can be, this is the reflectron, so they can be move again here and go to the detector. So that is nothing but such kind of system is used to in this is a V shape. In some instrument it is W shape. Just only check, we have to added a different shape of reflectron is there, so that used as a resolution. So did you understand the basic concept, how the reflectron can work over here and go to the, so here what will happen, because of that only they can use a they can reach to the same time instead of lighter ions faster and heavier ions later. So that is the important part in this case you have to focus. Okay, now can see the one more uh, mass analyzer, that is Fourier transfer ion cyclotron resonance, that is FTICR. This is also called it as FTICR. In some cases they have called it as FTMS also, Fourier transfer mass spectrometry. Okay, so this Fourier transfer ions cyclotron resonance, it is a type of mass analyzer. They can be used to determine m by z ratio that based upon the cyclotron frequency of the ions in a fixed magnetic field. So magnetic field is here kept constant and cyclotron frequency is increases, so they can get the m by z ratio. So FTICR, it is the highest performance of MS technique, and it gives a very high resolution and mass accuracy. This FTMS, commonly it is also called, instead of FTICR it is also called as FTMS. That is considered as an ion trap system, where the ions are trapped in the magnetic rather than in a quadrupole electric field. So here, instead of quadrupole electric field, they can use the magnetic field. So the ion citron resonance system, it is used as a superconducting magnets are there to trap the ions in a small sample cell. And this type of analyzer, it is extremely high resolution of mass, and that is useful for tandem mass spectrometry. So actually tandem mass spectrometry, it is a technique that use advanced part in the analysis. So all these part is included as a tandem mass spectrometry like TOF and that thing. So initial analyzers are very common that we have already seen at the very first part, that is magnet sector. But whatever the later part we have observed, all are included in the tandem mass spectrometry. So FTMS consists of ion source, mostly they can use electron spray ion system as an ion source. Some ion optics transfer the ions into magnetic field. So here we can use radio frequencies and ion citron resonance cell or penning trap that can be used to the analyze the sample ions. So in this way, here only here we can use the magnetic field instead of the electric field. So that is the difference. So such kind of question may ask in the MCQ. So you have to focus on that part also. So in Fourier transfer ion cyclotron resonance, so ions are entered into the chamber by trapping the circular orbits of powerful electric and magnetic field. So when excited by the radio frequencies, the ion generated time dependent current. So that current is converted to the Fourier transfer into the orbital frequencies, and which corresponds to their mass to charge ratio. So like ion trap, FTIC are also analyze multiple stages of mass spectrometry without additional any mass analyzer. So they're having a very wide mass range as well as excellent mass resolution is also there, but it having most expensive. So this is the magnetic field. These are the trapping plates are there. These are the detector plates, and this is radio frequency that can be supplied over here from these two sides, that is excited plates. And these are the ions. So these are induced alternative current is also supplied to the detector, and here we can get this is the induced we can obtain this in terms of ions, they can be obtain the signal. Then this Fourier transform is convert this induction decay into the signal of the frequency for particular m by z ratio, and then this is converted to the mass converter is there, so they can be converted to the mass spectrum. So again here is the resolution is carried out by using the Fourier transfer technique. So this is the Fourier induction decay is there, and on that basis we can get a very complication of the particular m by z ratio of particular ion is we can observe, and that is converted to the such kind of domain to the frequency spectrum. So from uh, this induction domain to the frequency domain, that can be converted by using this Fourier transfer technique. So excitation of the ion is takes place by using this radio frequency that is supply from the either side of these plates. So this is a very important technique. Just we have to focus on this by using the radio frequency. So magnetic field is applied over here, and on the basis of m by z, they can use the induction decay, and that decay is converted to corresponding signal, that is frequency uh, domain, by using the Fourier transfer technique. So that can be uh, very useful to convert each m by z ratio of particular ion to in the form of signal, and then they can be converted to the particular mass. This frequency is converted to particular mass, that is m by z, and here we can get the mass spectrum. So in this way, this Fourier transfer citron resonance is takes place. So that is nothing but the we have observed same technique in the previous example quadrupole also, that is radio frequency is used, so excitation is takes place, and that can give a particular m by z. Okay, so this is the uh, technique that is commonly used over here to get the m by z ratio. And by using this Fourier transfer technique, whatever the all induction decay is converted to the frequency domain. And so here these are obtained for particular frequency, and that frequency is converted to corresponding mass. So there is a mass converter is there, so we can get m by z ratio of particular ion. So in this way, this FTICR is takes place. So here the ions are excited by radio frequency, and on the basis of their mass to charge ratio, this frequency can be converted to the that FID is converted to the frequency by using the Fourier transfer, and then by using the mass converter they can be converted to the mass. So in this way, this technique is been very useful to find out the m by z ratio. So I think you have cleared this concept of FTIC. So just we have to change that whatever the ion source they can use now, they are fixed. So we have to just accelerate, that part is also there. And after acceleration, when we can pass to the analyzer, different kind of analyzers has been used, and they can be modified as far as the uh, compound is concerned, whether they are having a polymer, they are having biological background, or whether they are having a chemistry background. Such kind of compounds they can be analyzed on the basis of their need, and that's why they can use a advanced technique in this case. So this is the highest mass resolution in all mass spectrometry, which is well suited in ion chemistry because the excitation is takes place. Along with MS experiment, they can be commonly used. Again, it is suitable for MALDI. It is a non-destructive ion detection, and here ion remeasurement is also takes place. So mass calibration is stable in this case by using the superconducting magnet, and that's why the mass calibration is very stable in this case because of the use of superconducting magnet. But it having certain limitation, that is range is limited, low pressure requirement. Along with that, harmonic as well as side bands are present in the mass spectra. Then quality of the mass spectrum is influenced by the many parameters like excitation, trapping, detection conditions. So here the actual excitation is takes place, and that's why some influences may be obtained by using the number of other peaks are also there along with particular ion peak and parent ion as well as base ion, and whatever along with that some other peaks are also obtained because of the excitation. So low energy collision induced dissociation is there. Therefore, the spectrum depend upon the collision energy, collision gas, and other parameters are also there. So this collision induced dissociation, that is mostly in terms of induced decay, is takes place over here, and that's why they depend on the collision energy between the ions. Then it requires collision gas, and other parameters are also there, and that's why it having certain limitation. But it is used in the ion chemistry, high resolution MALDI, and electron spec experiment. Laser desorption for material and surface characterization is also very useful by using this FTICR technique in the analyzer. So there are some applications of this FTICR also there. Now, all these we have classify the different analyzer. Along with that, tandem mass spectrometry is also there. So mostly they can use triple quadrupole and other things. So that we will see probably on the next lecture how the some advance and along with the application that we will see that part. Now we'll move towards the detector. So once ions are separated in the mass analyzer, they can reach to the ion detector. So that can convert or generate a current signal from that ions. So mostly used detectors in mass spectrometry are the Faraday cup, electron multiplier, photomultiplier diode, and induced detector. So electron multiplier and photomultiplier are commonly used diodes as a detector in that case. So we will see one by one shortly. So Faraday cup. So Faraday cup involves the ion strike the diodes, that is the surface, which causes the secondary electrons to be ejected. And here this is a temporary electron emission that includes the positive charge on the detector and therefore current of the electron flowing towards the detector. This is the induced current. So we can pass these electrons. no doubt is a temporary. So from this ion beam is there, and then they can give the signal to the amplifier. So this detector is not particularly sensitive, offering limiting amplification of the signal, and it requires high pressure. And that's why no doubt it is a very beginning or with initial stages this Faraday cup detector has been used. Just we have to fall on that detector the ions, and here they can be, that is ions are striking the diode surface, and which causes the secondary electron to be ejected. So in this way they can be converted to the signal. These ions are converted to the signal. Then electron multiplier, this is commonly used. uh, in this case it is made by a series of aluminum oxide diodes that maintain at ever increasing potential. The mostly MCQ can be asked on this part. Then ions strike the first diode surface, causing emission of electron, and these electrons are then attracted to the next diode, which held in the high potential, and that uh, generate secondary electrons. Ultimately, the numerous diodes are involved in this case, and the cascade of electron is formed, and as a result overall current gain on the order of 1 million or very higher. So high energy diodes that are used to accelerating the electrostatic field and increase the velocity of ion, that increases the signal intensity and sensitivity of the particular ion, and that can be reflect on the mass spectrum. So this is the ion that are entered to the slit in the detector. So detector having such kind of series of diodes of aluminum oxide, which can increase the potential. So they can be just striking this, and if you observe uh, they can emit the electron, and as they can strike on the diode, so that goes on slowly increasing. So that can give the high signals for particular ion, and that gives corresponding. So here this is a cone shape system is there. So this is linear, this is cone shape, so that can be also use the same technique. So so here due to this the velocity of the ions is increases, and that can be converted to the signal, and that signal is plotted on the paper. So that is the role of only detector, because the ions with particular m by z ratio is entered into the slit, and they can directly fall on the detector. So in that case the detector is used in a such a way that uh, each ion that can gives the intense peak, and that peak is obtained by using the that can be having a increasing the potential of ions, and that gives the electrostatic field that increase the velocity of the ions, and signal intensity is increases. So why this can be used in the detector, so they can increase the signal intensity and also the sensitivity. So these two shape electron multiplier can be commonly used. So mostly this electron multiplier is used in the part of a detector. Okay, now we will see the photomultiplier conversion diodes. It is a photomultiplier which is not commonly used. It is similar to the electron multiplier design, where the secondary electron strike the of phosphorus screen instead of diode. So that is the very important part. This phosphorus screen release the photon, which is detected by the photomultiplier and then amplified using the cascading principle. So one advantages of converging diode into that photomultiplier tube is sealed in a vacuum and unexposed to the environment of mass spectrometer, and that can be uh, contamination is should be removed. So only instead of dynode, this secondary electron is strike on the phosphorus screen instead of dynode. That is the only important part. So these are the ions that are enter into this, and this is the phosphorus screen. Okay, so this is the first dynode position, that is positively charged. The secondary electrons are there. Now when they can be these ions are reached over here, they can be bombarded on this phosphate phosphorus screen. Actually, that is the photomultiplier tube is here, and these are the photons, and then they can be accelerated over here. So they can be converted to the dynode which having negative charge, then enter over here and then go to the detector, ion beam detector. So this is the photomultiplier convergent dynode that is used only for the second part of a series of dynode. Here they used a phosphorus screen, and that release photons which is detected by the photomultiplier, and they can amplify the corresponding ions, and they enter to the ion beam detector. So this is the only change. The function is similar to the electron multiplier, and that's why electron multiplier is commonly used in the detector. So that is very important. Detector are commonly same. They didn't change much more. Then array detector is also there. In array detector, it is a group of individual detectors aligned in a array format. That is one after another. So which specially detects ion according to their m by z, and they're having used on magnetic sector of mass analyzer. Specially differentiated ions can be detected simultaneously by array detector. So the primary advantage of this approach is that over a small mass range, scanning is not necessary, and therefore sensitivity is very important. Here they have used diode array, then optical slit is there, detector flow cell is there, then again the filter is there, then different chromatic lanes are used, they can be passed over. So that is nothing but this is the visible lamp, UV lamp is there. So from this visible lamp, UV lamp, they can pass the signal. Then achromatic lanes are there. Then here we can get the filters are attached over here, and detector flow cell is there, and through this they can use the diode array. So this is the array detector part. Along with the ions, they can use a such kind of a series of detector, individual detector. They have been attached over here in a array format, and according to the m by z ratio, they can give a uh, corresponding peak. So this is the array detector, and now we can see the inductive detector, that is the charge detector is also there. So here charge detector simply recognize a moving charge particle, that is ions, through the induction of current uh, on the plate as ion move past. This type of detector is widely used in FTMS to generate the image current of ions, and this detection of is independent on the size of ions. Uh, if you observe, this is the ion source by using the ESI, and they can pass to the analyzer, that is TOF, and then this is a charge detection, that charge detector is used, and then they can be converted to particular signal of m by z. So on that basis, they can be along with the charge particle, it can be moved or induced of current on the plate of detector, and that can be give convert to the signal. So that is the only principle of this charge detector. Now we will see the whole this system we have observed. It is kept in the vacuum system. So in order to work in a predictable and efficient way, mass analyzer requires high level of vacuum. So that are analyzed under the investigation must be manageable and sensitive to the electrostatic component of the instrument. So the vacuum technology is used to remove the background molecules as a deflection of ions by a spectrometer uh, on a specific pathway, so that cannot be influenced the actually peak. So only under the influence of electric, magnetic or radio frequencies they can be removed, otherwise result in the deviation due to the collision of these all things in the particular MZ ions it takes place. So that's why this vacuum system is very essential to remove such unwanted influences from the MZ ratio of particular ion. So high level vacuum within the instrument prevents the deviation of the analyte ion from the specific path, so they can be uh, gives a particular m by z ratio, and they can directly go to the detector, so they cannot be any kind of deviation should be takes place because of the vacuum system. So by providing the adequate mean of free path of analyte ions, also separation is takes place over here by using this vacuum system, uh, facilitate the collision free ion trajectories, reduce the ion molecular reactions, and minimize the background interference. So that is the role of vacuum system. Why there is need of vacuum system? So they can reduce the background interference, they can reduce the molecular ion interaction further, and particular m by z ion can be detected. So this thing is carried out by a vacuum system is given with high level, otherwise we can get a number of collisions are there. So that are the important part why there is a need of a vacuum system in whole this spectrometry that we have observed. So there are some common vacuum pumps are used, that is rotary vacuum pump, Furlan vacuum pump, then turbomolecular pump, and diffusion pumps are used in this case. And we have observed whole this system is in a vacuum system. In a very first diagram of this mass spectrometry we have already seen. So sample inlet, then ionization source is also inside the vacuum, then these are the vacuum pumps, this is the analyzer, and this is the detector. So whole this system is in a we have said that at that time also that this is the outlet, and that outlet is nothing but that vacuum pump having this outlet, so they can be collect uh, cryogenic pump is there. So diffusion or turbo molecules they can be enter over here, that is negative ions, some other ions, and they can be passed to the mechanical pump. So this is the outlet actually, whatever the unnecessary part is there, and they cannot be interfered actually ambiguous of particular ion, and they can be given a direction of mass analyzer to the detector, and this whole thing is carried out by vacuum system of high quality. So in this way the vacuum system has been done. I think the basic part of whole this topic is covered. Only one thing that I would like to mention over here is that in this case really there is a need of the part. I think Afsana has asked me at the very beginning of this topic when I have started whether this organic part, that whether I will take or not at that time. But I think as far as the analytical chemistry is concerned, mostly this is the important part as far as instrumentation is concerned. Probably on next lecture I will focus on the tandem mass spectrometry. That is a part of triple quadruple and some MSMS, LCMS, whatever the part is there, few slide, and then I will focus on that part also. That is the application of mass spectrometry. So no doubt, whole mass spectrometry application for detection of the mass and how they can be detected. Application part, that is how they can be form molecular ion peak, base ion, then fragments ion, how they can be carried out, the which kind of reaction is carried out, how rearrangement is takes place, whatever that part is there. Probably on that lecture I will cover the part. I think Apsana has asked me that part actually on the very beginning, that whether we will see that peaks mostly organic chemistry students required. But as far as the analyticals are concerned, uh, one lecture we will focus on that, how the signals can be obtained, and basic thing that you have already learned I think at um, first year, right Apsana?
Yes, sir.
हां. तर मला वाटतंय आपण त्या ठिकाणी जे काही बेसिक पार्ट जो अनालिटिकल पॉईंट ऑफ व्ह्यू होता तो बऱ्यापैकी आपण कव्हर केलेला आहे. पुढच्या एखाद्या लेक्चरला आपण थोडंसं टँडम मास स्पेक्ट्रोमेट्री आणि हे जे काही आयन्स वेगवेगळे तयार होतात ऍप्लिकेशन पार्टमध्ये, तर ते आपण त्या ठिकाणी पाहू. आणि पुढच्या लेक्चरला ऑलरेडी हा टॉपिक संपलेला असेल आणि त्याच्यानंतरचा एक टॉपिक माझ्याकडं दिलेला आहे. म्हणजे तसं पाहायला गेलं तर ऑर्गॅनिकचा प्राध्यापक असतानाही मास स्पेक्ट्रोमेट्री मॅडमनी माझ्याकडे दिला. त्याचं एक कारण म्हणजे कदाचित पीएचडी करत असताना मी थोडंसं त्या पार्टकडे म्हणजे मास सगळ्यात जास्त मी काढले. त्याचा एक पार्ट असावा. आणि त्यामध्ये जेव्हा आपण एखादा स्पेक्ट्रम काढतो तेव्हा त्याची थोडीशी थिअरी पण आपण पाहतो. आणि त्यामुळे मॅडम म्हणाले की तुम्ही त्याला थोडंसं न्याय देऊ शकता. आणि पहिलाच अटेम्प्ट होता, त्यामुळं मी कदाचित तुमची जी काही रिक्वायरमेंट असेल तिथपर्यंत पोहोचू शकलोही नसेल, परंतु माझ्या परीने जेवढं त्या ठिकाणी त्या टॉपिकला न्याय द्यायचा येत होता तेवढा मी नक्कीच दिलेला आहे. मॅक्झिमम पार्ट मी त्या ठिकाणी तुमचा कव्हर केलेला आहे. प्लस जेवढं द्यायचंय ते मॅक्झिमम मी त्या ठिकाणी दिलेलं आहे. फक्त तुम्ही त्याची प्रिंट काढा आणि मला वाटतं ते जर केलं तर कुठल्या रेफरन्स पुस्तकाची गरज पडायची नाही असं मला तरी वाटतंय. कारण बरेच वेळा काय होतं, रेफरन्स पुस्तक आता सुदैवानं पीडीएफ फॉर्म मध्ये अवेलेबल असल्यामुळे आपण ती दिलेली आहेत. पण पूर्वी तसं नसायचं. त्यामुळे हे मटेरियल तुम्हाला नक्कीच त्या ठिकाणी त्या चॅप्टरसाठी उपयोगी पडेल. आणि पुढचा जो टॉपिक आहे हा थोडासा ऍडव्हान्स आहे आणि एक पर्टिक्युलर असल्यामुळे त्याला कदाचित एवढे लेक्चर लागणार नाही जेवढे आपल्याला आता इथे या ठिकाणी लागले. परंतु तो घेत असताना परत एकदा थोडंसं बेसिक क्रोमॅटोग्राफी संदर्भात सांगावं लागेल. आणि तो सुद्धा पार्ट ऍज अ पीएचडी मध्ये जे काही कॉलम क्रोमॅटोग्राफी असेल, टीएलसी असेल, हा जो पार्ट मी पूर्वीपासून करत आलोय हे मॅडमला माहिती होय. आणि त्यामुळं कदाचित मॅडमने तोही टॉपिक माझ्याकडे दिलेला आहे. आता ते दोन टॉपिक माझ्यासाठी तसे नवीन आहेत, परंतु डेफिनेटली त्या टॉपिकला सुद्धा आपण एक चांगला न्याय देऊ आणि लवकरच तोही पुढच्या ह्याला आपण सुरू करू. कदाचित मॅडमला आता इथे जॉईन होता येत नसावं त्या लिंकमुळे. तर मॅडमला ऍक्च्युली मी शेड्यूल केलेला आहे, तिथे काय शेड्यूल दिसत नाही मला पाहावं लागेल. परंतु तुम्ही मॅडमला तसा निरोप द्या म्हणजे मग मॅडम मला वाटते त्या ठिकाणी जॉईन करतील. ठीक आहे. त्यामध्ये कोणाला काही शंका आहे? जर शंका असेल ह्या टॉपिक बद्दल तर तुम्ही मला व्हॉट्सअपला कळवा, म्हणजे पुढच्या लेक्चरच्या वेळेस आपण तो पार्ट परत एकदा डिस्कस करू. हम्म? ठीक आहे.
ओके सर.
ओके,
ओके.
थँक्यू.
अच्छा ना.
हाँ बोल ना.
इससे लीव करते हैं ना मैम, नया लिंक क्रिएट कर रहे हैं ना अभी.
नहीं पता मैम का मैसेज आया क्या?
हाँ मैसेज आया ना, देखना.
हाँ हाँ
ट्राइंग टू
आया आया.
क्रिएट लिंक करके. तो अभी
ठीक है
इसका
फिर ये
जरूरत
लिंक.
नहीं है ना.
हाँ
या
मैम
फिर ये लिंक
करेंगे के लिए.
भेजे क्या मैम को.
ठीक है मैम को इनवाइट करते हैं. देख भला बीच के मैम को
पर वो
पूछ उनको.
ऑलरेडी ग्रुप में है ना. चवन सर ने ऑलरेडी
नहीं
भेजा
मैम
है.
ही है यहाँ पे. हाँ.
क्या करना है.
यहाँ पे ऑप्शन ही है. पूछना मैम को बोलना यहीं पे आप
मैम
ज्वाइन
को
करो.
बोले क्या, हम इस लिंक में वेट कर रहे हैं.
हाँ ठीक है मैम को ही बोल मैम आप ही इस लिंक को ज्वाइन करो. देख रहा है.
हेलो हेलो